Hello. Let me just quickly check. Maybe probably. Let's go. Hello. Right. Yep. So we could start. By the way, I made some progress. This is where I'm right now. And this is the current stage where we are. ESP32 with the LCD. I was able to connect them via SPI protocol, and some data transfer is happening, but I still need to dig a little deeper to understand the whole ecosystem, how it works. So आज mainly will be trying to finish till we draw something on the board basically. By the way, lot of things like debugging में time लेना दिमाग खराब हो गया था, but it's fun also. So yeah, correctly in SPI is basically, so SPI is a protocol, serial peripheral interface protocol, and how that works is there are 4 channels generally: clock, OSI, MISO. OSI MISO is basically master out, slave in, master in, slave out. So ESP32 LCD को भी बात कर सकता है, LCD इससे बात कर सकता है. But apparently I got confused कि why, if we have this channel, then what is the point of DC? DC is basically the one which basically lets the, so think of it like this, that display is not directly connected with the ESP32. There is a board in between, and that board is, there's a different IC which is ILI 9341. That board, so ESP32 talks to that guy, and that guy has its own RAM, and that guy controls the basically screen. Okay. And DC0 basically tells कि एक command है क्या या data है. Okay, why some SPI in LCD needs DC? SPI itself has no concept of command versus data. SPI only moves bytes. It needs to know, is this byte an instruction or is this byte a command parameter? Just send another bit for that. Okay, there are actually that's good that I'm thinking in that direction. So there are 2 common ways LCD modules solve this: 9-bit SPI and 8-bit. 9-bit you have, first bit says command or data, fewer pins. 8-bit SPI does that. Okay. The config structures. Yeah, I wanted to learn more about these data types that we have used. For example, this. Yeah, it worked. Let's just fuzzy grab. I can do like .h with the text or something. So we want to find this struct where it is SPI bus config. Oh wow, stupid document. If I know it is a struct, I can just do this, right? No, but I can do this apparently. Okay. Type of struct union int. I don't know what is the union. इसे पूछ ले क्या नाम है. I could have gone to Claude or Codex. Yeah. It's union. Let's see and how to use it. I'm trying to bring this into my practice where I use local models for the things where I don't need special AI agents, because there are lots of knowledge on the internet and this even models must have been trained on that. Union are one of the most confusing concepts in C. Thank you. Especially when compared to the struct. Here's a complete breakdown of C. How do you effectively union C? The definition C. A union is a special data structure that allows you to store multiple different data types, variables under the same memory address. Okay. Unlike struct, which allocates enough memory for all its members and lets them coexist independently, union treats all of its members as occupying the same physical space in memory. Okay. The key concept, shared memory. When you declare a union, a member is allocated only enough room to hold the largest member within the union. If you write data to one member, then read from another member, the first piece of data will be overwritten or corrupted. If you write data to one member and then read from another member, the first piece of data will be overwritten. And yeah, because you allocated not enough memory for them to coexist independently. Union versus struct, crucial difference. This comparison, इसका use case क्या है अभी तक clear नहीं हुआ मेरे को. This comparison is essential for understanding when to use union. Okay, this is where I miss a classical codex or plot. Because they render tables very cleanly. Memory allocation reserves memory for all members combined. Yes, reserve for largest member. Yeah, reserve. Okay, this is for union. Data storage, all data previous amount. The one data item can exist at any given time. Container that holds many separate pieces of information, like a car holding the pen, shared space, electrical socket that only fits one plug. An apartment building, each current member is self-contained, so a single drawer in a toolbox. You can put a hammer or you can put a wrench, but if you put takes most of the we use a code example. Let us look at the example, but never ever. Imagine a payment system. A person pay user either a floating point number salary, or they might use a fixed point integer if we only need space for the largest potential payment. Union payment, which is a float, which is a 4-byte, end byte, double bank transfer, which is a 8-byte. So it should take 8 bytes. Union payment P, printf memory allocation, printf size of double is this will be also 8 byte. P dot bank transfer is equal to P dot bank transfer. Oh, okay, so P is the object of this type, and printf transfer is equal to P dot bank transfer. Okay, overwriting the database. I decided to switch modes and store a salary instead. P dot salary equal to this. What is the use of this? It's like somebody. I might be completely off the topic, like might be completely wrong, but I don't understand what is the use of. Let's go to standard GPT. What is the use of giving it? इसको बंद कर देना। Okay, yeah, yes. We have this. This is 4 byte, 1 byte, so you'll get 4 byte. I get that much. That I understood. But why are we doing this? The main idea is I have one block of memory. Sometimes I want to treat it as an int, sometimes as a float, and sometimes as a car. Yeah. Oh. Is it like, can I say like it is a polymorphic data structure which can take different forms? Let's see. Okay. Suppose we want a variable that can store either integer, float, or string. Type int, value type. That value type in int v dot type full diamond data इसको दे दिया, ठीक है. V dot type float to int. Yeah. Okay, I get the idea. Like it's like fixed memory, and then you are kind of allocating a tag or a key, and that specifies which type of. But I guess kind of makes sense when you want to store. I'm still not 100% sure about the use case, but it kind of makes sense because I'm thinking from practical point of view. Let's say you have 10 people, and for some people, and you can store only one kind of name. So for some people you might have nicknames, and for some people you have only names, and you don't want to allocate two different memory. So you can have a single memory, and nickname could be also string, this can be also string, and then you can specify that on the top. That could be a use case, but that's what these guys are doing, right? And this pattern is apparently extremely useful. The type field tells you what is currently inside the union. Yes, it's called tagged union. Okay, before we do so much judgment, I guess it's better if we write a small C code for that. अपना हाथ में फ्री हो जाए. We'll do vi temp.c cdio.h, and okay, I realize I'm in vi instead of vim. That's okay. And then here I will do printf applications here. And it's always important to write code when you're learning something, because we will define a struct and we'll call it books. You can have something like s. That's what it is saying, right? And then maybe we can also define something like int a, or let's call it int id. We'll call it name. So you have a book structure which has an id, which has a name, and which also has, let's say, price. But price needs to exist. So yeah, and then you can also define, how do you write union like this simply, right? We have the source code here, right? Small, yeah. So I can also define, I'll call it compact book, as it is taking less memory. And this will have something like enum, the tagged identifier. So enum will have something like, that's what this guy is also doing, right? Tagged on. Type in type float, that will be a value type. Type in. Now it could be as a book type, and we'll call it enum would be by id, enum would be by name. Alright, and then this union will have a book type, right? Yep, book type as a type, and we'll have that this, I think struct ऊपर still struct होगा, right? Yeah, just struct ही होगा ऊपर. Okay, this will still be struct, that will be a type, and then you will have char star name and int id, right? And then you can basically I can define something like struct book b is equal to struct book केवल लिखा मैंने, null print size actually, print size of book as percentage ZU. This will be size of B, and then we'll also print size of compact book. This is ZU. Size of CB. We'll create that here. Just compact book CB. We got right. Written. Let me quit it. gct10.c. Expected. It's okay, guys. It's okay to make mistakes in C. That's how you learn. You don't have to be like, hey, how can I make mistake like this basic mistake? So, and you should know how to read these errors. So it says expected equal to constant expression. इनमें कॉमन सेमीकोलन नहीं लिखते हैं क्या? How do you written comma? Okay. Replace comma. Right click. And now let's try this. Okay. So at least that error is gone. Then it is saying line number 12, which is book type. Again same thing. And here also we'll have to find union, right? That's how it was written here. Union. Have to write undo हो गया वो. Replace comma. Go to the line here. Union. Write and save this. Unknown type book type. Same thing, right? Oh, it says type def enum and then bracket. We did not do that. Because here you have to do type def. Okay. So line number 14 error is at least one. Now we have error in line number 15. Expected semicolon after the declaration. Okay, so that was right. Go above, go to the end of the line by shift dollar, replace with semicolon. We can do escape. Got written. Compile again. So line number 15 error is gone. Now we are at line number 19. 19 and we need a column here also. Shift, insert, now semicolon. Okay, written. That is gone, right? No. 19.1 is still there. Line number 19. This here maybe we'll also have to write. Yes, sir. That's made a lot. 16 bytes to both of them. तो कुछ तो हमें अलग करना चाहिए था एक्चुअली. ये स्ट्रक्ट जो है इसमें एक तो वैसे इसका 16 बाइट कैसे गया. I think we should do is let's fix the size of this. तो कर देते हैं 20 बाइट का. एंड यहाँ पे भी हम कर देते हैं. आई थिंक तब ज़्यादा क्लियर समझ में आएगा. 20 बाइट रिटर्न फाइल. तो ये लिया 20 बाइट, लिया ये 4 24 बाइट. यहाँ पे ये लिया 20 बाइट, ये इनम लिया 4 बाइट. ऐसा है क्या? हाउ डू आई just for the sake of argument I'm adding a float also here. Alpha dot beta, and we'll do the same. Let me just yank that instead of writing it. Keep yank to J, yank to J. हाँ, now is the difference. अब समझ में आएगा ज़्यादा. तो ये गया, ये तो 24 बाइट था, ठीक है. 24 के बाद 4 4 8, 24 और 8 32 लिया. बट ये 24 क्यों लिया? अच्छा, 4 ये लिया और 20 ये लिया, 24 ये लिया. और इसको लग गया, हाँ इसको लग गया कितना? 20 और 4 24, 4 28, 4 32. ओके ओके ओके, ठीक है, मेक सेंस. नाउ वी कैन जस्ट क्विट. थोड़ा यूनियन अपने को जम गया. गुड टू लर्न न्यू डेटा स्ट्रक्चर. सो वेयर वी टाइप दैट स्ट्रक्ट पूरा एक यूनियन है. A union of a struct of a union. You know what? अभी इस पे इतना इन्वेस्ट नहीं करते टाइम. It's not worth it. What we'll do is we'll just assume that this is one big struct जिसमें डेटा रखा हुआ है. Then you have data.io default level int max transfer sc, maximum transfer size, and ESP32-S3 CPU is here. It selects CPU port to register SPI/IDF. Okay, and interrupt flags. Okay, तो यहाँ से अपन देखते हैं इसने पहले हमने बनाया बस कॉन्फ़िग, मैं यहाँ पे कमेंट लिखते जाता हूँ, क्लियर रहेगा। पहला स्टेप है बस कॉन्फ़िग डिफाइन किया। तो कोई भी डेटा ट्रांसफ़र होगा IC to IC will define a bus, especially SPI specifically हमारे लिए, but we can keep this thinking in general। और हमने यहाँ पे पिन्स बता दिए उसको, कौन कौन से पिन किस किस जगह पे हैं, और ये पिन हमने यहाँ पे डिफाइन कर दिया है यहाँ पे। एंड देन वी हैव डिफाइंड ESP LCD channel, ESP LCD panel to panel IO handle T। I don't know what is the point of that handle T, but that is also a type। लेकिन हमारे लिए ये इम्पोर्टेंट है। LCD panel IO SPI config, LCD panel का जो कॉन्फ़िगरेशन है वो हमने डिफाइन किया है यहाँ पे। पिन नंबर LCD DS, PS चिप सेलेक्ट का पिन है, क्लॉक स्पीड है, और DC is that data control a bit, okay, which makes sense, right? Apart from, तो यहाँ पे हमने जो बस कॉन्फ़िग डिफाइन किया है, दिस इज स्टैंडर्ड SPI प्रोटोकॉल, जिसमें आपके 4 पिन होते हैं, राइट? यहाँ पे कितने डिफाइंड है? 3 ही है। चिप सेलेक्ट मिसोमोसो चिप सेलेक्ट यहाँ पे नहीं है, चिप सेलेक्ट अपेरेंटली यहाँ पे है, ठीक है। And then we defined ESP LCD panel SPI conflict will do yank word paste up, loving it, maybe I'm not, 50, yeah, with the line, there you go। This is LCD panel choice, इसमें हमने क्या क्या देखा? Specific to that LCD, we can have chip select, data control, and और क्या होता है इसके पास? हाँ, 2 ही चीजें, बाकी तो clock speed। This is not actually clock, this is more like refresh frequency also, जो monitors का होता है 100 Hz, 144 Hz, 60 Hz, how frequently your monitor can refresh। जैसे ये मेरा monitor 144 का है, can refresh very fast। So we define this configuration, and then ESP LCD new panel IO SPI, इसको हमने दिया this is IO config and IO handle, ESP LCD new panel, okay। तो ये जो कॉन्फ़िगरेशन है इसका हैंडलर है ये, ओके। फिर हमने बनाया है LCD पैनल हैंडल। माय गॉड, देयर सो मेनी थिंग्स हैपनिंग। इसको बोल दिया हमने वेंडर कॉन्फ़िग, एंड देन वी हैव डेव कॉन्फ़िग। इसमें क्या लिखा है हमने? रीसेट पिन, एलिमेंट अलाइनमेंट, और इसमें क्या है? ये वेंडर कॉन्फ़िग। और ये सबको मिला के हमने एक फाइनल एक हैंडल बनाया, ठीक है, पैनल हैंडल। और ये पैनल हैंडल में ही सारा काम हो रहा है अपेरेंटली। बाकी जितना मेहनत किया हमने उसका कोई काम नहीं है, ये पैनल हैंडल से ही मतलब है। सो आई कैन मे बी रैप दिस होल थिंग inside a function to keep our code clean. Should I do it? Try that? And what is the type of panel handle? Yeah, we can do that. Let me just do this. थोड़ा रिफैक्टरिंग भी करते रहेंगे ना, तो सीखेंगे. So from here delete 31J. Okay. We'll call it void get me panel, and this guy will do nothing for now. We'll just paste everything here, and here we'll write, we'll take that pointer. What is that pointer type? It's panel handle, right? The panel handle, there was a null pointer, right? IO handle is there. This is the panel handle. Yan word. We'll paste that here, and we'll take that pointer. We'll call it panel handle. And we'll delete, we'll define that here, then we'll take this from here to line number 14. So delete 14J. Yes, we'll paste that here, and we'll call that function. We forgot to call that function. The function का नाम है yank w, and then paste get me panel. We'll call this guy with address of panel handle. Why I am doing all this? Just to keep our code clean. Written. Now I can do IDF even build. Let's see. The photo. Ninja build stopped. ESP32 incompatible. What is incompatible? बाकी सारा चीज तो अंदर ही डिफाइंड था. ओके, दिस यहाँ पे पैनल हैंडल था, वहाँ पैनल हैंडल जाएगा. यहाँ पे should we try doing that? Replacing एक ही बार करते हैं. भी डॉलर जाएगा, भी एड्रेस जाएगा. नाउ दैट वी आर पासिंग द पॉइंटर, तो हर जगह जहाँ पे पहले वो जा रहा था वहाँ पे ये जाएगा. जहाँ पे एड्रेस जा रहा था Note this declared here passing argument 1 of int from incompatible. It is saying what I'm passing is incompatible. Why? क्योंकि currently it is null. Is it because of that? इनका कोई एड्रेस नहीं होता है इसलिए maybe. तो इतने साल shitty programming languages में काम करने पे यही होता है. Your basic brain is like frozen. You do shitty things. Even that guess that I did right now was stupid. Because the type is defined, right? I'm just passing a pointer to that. That pointer is coming here. And that pointer is getting used here. तो जहाँ पे उसका एड्रेस चाहिए था वहाँ पे जा रहा था. Let me try this. No. ठीक है. Fetch display code and tell me why that failed. So this is also you can learn, right? आज के टाइम पे it's okay. Make mistakes, learn from it. Cycle task ये क्या लेता है? हैंडल लेता है. हैंडल निकाल के fill red, fill screen लेगा हैंडल and address. Oh, this is that color क्या? So we have to find this one. Takes a panel and the color, yes, and ours is 16-bit. यहाँ पे देखते static 16 LCD का height resolution because the function signature ESP is already a SPL handle is okay. This is already a pointer. No, we defined it as a pointer. Achha, it has been defined as a pointer. So inside get me panel this a pointer to a pointer. This line is incorrect. Okay. We should have dereferenced it. Okay. Fix it. Fix. So we have a 16-bit. 16 byte. बिट ही हुआ था. 16 बिट का नंबर का एक एरे लिया. वो एरे कितने साइज का लिया? एच रेजोल्यूशन इनटू लाइन काउंट. ये लाइन काउंट कौन सा है? तो ये हमने ऐसे डिफाइन किया 20. इसका लाइन, ठीक है। इज इक्वल टू 0 to लेस देन पूरा I प्लस प्लस, ठीक है। लाइन बफर I to पैनल कलर। Why not just write the whole thing in one go? But I get it, like it's a two-dimensional data in one-dimensional array, so that's what we are doing it. That's why we are doing it. But still, you can batch it. I don't know how much that will cost. Okay, anyway, y is equal to 0. That's the vertical resolution, y plus line count, and then you are doing raw bitmap, that panel horizontal resolution, y plus LCD line count, and that's line buffer. This is basically drawing them. Every 20 line is getting drawn in every iteration, is it? So if I increase that number, it should feel different. And then we have swap, color swapping कर रहे हैं, कुछ fancy सा bit manipulation, which is fine. Did it not fix it? Fix it, yeah. So that's what it was. Since it was already a pointer, we were supposed to dereference that pointer जहाँ पे उसका वैल्यू जा रहा था, वहाँ जहाँ पे एड्रेस जा रहा था वहाँ पे किसी को भेजना है। Yeah, works. Little bit interested in this one also. एक 16 bit का नंबर है, तो we know RGB में R 5 बिट यूज हुआ, G 6 बिट हुआ, ये 5 बिट हुआ। अच्छा, ये था, इस पूरे को आधा इधर घिस कर दिया, तो RGB का 8 बिट घिस कर दिया है। 8 क्यों घिस का है, 8 इधर घिस का है, ये तो पूरा चेंज कर देगा ना कलर। How is that a smart thing to do? Okay, what is our colors? Let's wait. So there are two major components screen में. One is your LCD, and there is another sensor which is touch screen. And so far what we have done is कि हम LCD display करवाए हैं. That's what you should always do. छोटी छोटे चीज़ों को पहले अचीव करो, then club it all together to create a complex system. Any system of work should follow this. Like even in software development, we do the similar strategy. तो यहाँ पे मैंने lessons भी बनाए थे इससे. Where are those lessons? This we have done. Next हमारा ये बनेगा टच कंट्रोलर. Confirm yes when drawing the blocks, top left pixel. Okay, it is saying screen geometry समझना भी important है, but we'll skip this because I think screen geometry और वो सारा चीज़ हम बाद में भी करेक्ट कर लेंगे. मतलब once the touch is there, I can still use that coordinate system, right, to fix it. Let's skip this and focus on touch integration. So we can use touch also to fix the coordinates. It kind of makes sense. तब तक इसका थोड़ा वो पढ़ लेते हैं हम. ये हमारा जो सेंसर है, सेंसर इज बस IC इज 424.3046 का डेटा शीट देख लेते हैं. Whenever you are dealing with electronics, always try to go through द डेटा शीट. मतलब स्टार्टिंग में शुरू में नहीं समझ में आएगा ज़्यादा, मेरे को भी अभी उतना नहीं आता है, बट ओके आता है. बट इट्स मोर अबाउट गेटिंग यूज टू टर्मिनोलॉजीज, गेटिंग यूज टू थिंग्स, ताकि वो शॉकिंग नहीं लगे. एंड इट कम्स टू एनी फील्ड ऑफ लर्निंग कि जब भी कुछ नया चीज़ पढ़ते हो ना, तो इसको मैं बोलता हूँ इमर्सिव लर्निंग, वेयर यू बेसिकली अंडरस्टैंड द होल थिंग कि क्या चल रहा है. और विल डू ऑन नेक्स्ट. तो लो वोल्टेज IO टच स्क्रीन कंट्रोलर है ये, नेक्स्ट जनरेशन वर्जन ऑफ द समथिंग. वी सर्च फॉर HR2, मे बी इसी का नाम. ओके, इसी का नाम होगा, तभी लोग ऐसे बोल रहे हैं. अब जैसे मेरे को नहीं समझ में आ रही ज़्यादा चीज़ें, बट आई एम स्टिल गोइंग थ्रू इट, ताकि वो एक तरह का डर होता है. अनफेमिलियरिटी इज डेंजरस या फिर fearful. It has nothing to do with knowledge. Like humans have always been like that. Even when we were caveman, अचानक से कहीं आवाज आ गई. If you don't know, you get scared. Okay, बफर ऊपर कुछ है. ठीक है, थोड़ा बहुत आइडिया है मेरे को. फिजियोमीटर टाइप का ही कुछ है. और वो काम कैसे करता है? मे बी दैट होल सीट इज लाइक रेजिस्टेंस, जैसे पोटेंशियोमीटर में हम नापते रेजिस्टेंस, मे बी वैसा ही कुछ है. उसमें टॉगल होता है ना डिस्टेंस या फिर एंगुलर मोशंस, दैट चेंजेस द रेजिस्टेंस. सो मे बी समथिंग सिमिलर टू दैट. विल रीड अबाउट इट लेटर. दिस होल जर्नी विल कीप एक्सप्लोरिंग द प्रोडक्ट्स. सो अभी तो स्टार्ट हुआ है. Now it says bring up the touch controller after the LCD works. Touch is a separate device usually on the same SPI bus with its own chip select. Okay, so SPI control में हम protocol में हमने पढ़ा कि you can have separate bus and it's a resistive touch controller. Shared pins are clock, MOSI, so separate pins are okay. Oh, let me see. Is it already sorted or? I don't think they would have done that. मेरे को वो करना पड़ेगा. So I will need breadboard. Finally, I was trying to avoid it. We have breadboard. छोटा वाला ही use कर लेते. इसी पर. Clock, MOSI, MISO will be shared. Separate pin will be chip select. Makes sense. PDCS and TCS हाँ ओके, दैट्स व्हाट आई एम सेइंग यार। एआई कभी कभी ना ऐसे लिख देता है कंफ्यूज करने के लिए। ये तो ऑलरेडी अलग है भाई, मेरे को पता है। टीसीएस इज द न्यू वन, टीआरक्यू इज ऑप्शनल, इट्स इंटरप्ट स्विच, ठीक है। components ESP LCD IDF path component examples PT2046 is the touch part again. Okay, it says इसका already example है। Let's see. It's PT2046 touch controller XPT2046 via SPI. All right. ESP LCD component हमें देखना पड़ेगा। It says this ESP is called components में JK LCD, there we go। SPI है हमारा। ओके, सो दिस इज लाइब्रेरी जो उन्होंने लिख दिया है किसी और, जैसे LCD का था वैसे, नहीं स्क्रीन का था वैसे ही इसके लिए LCD ऑन दे, वो SPI स्पेसिफिक था। दिस इज LCD क्या exact API depends on selected touch driver component to shape it. Configure touch SPI with TCS. Optionally configure TIRQ. Read ROM. This is what I was saying, right? They have, by the way, I keep going to mouse, वो मैं avoid कर रहा हूँ। I have to get used to Vim. Raw coordinates are not pixels. Oh, raw coordinates are not pixels. You need calibrations. ठीक है, ये तो मैथ्स है, मैथ्स तो इजी है, मैथ्स तो फिगर आउट कर लेंगे। वी आर मोर इंटरेस्टेड इन गेटिंग द रीडिंग्स, एंड एज पर माई अंडरस्टैंडिंग दिस कॉम्पोनेंट का जो हेडर फाइल होगा उसको इंक्लूड करके हमें ये टच रॉ रीड करके जो है ना, ये हमें उठाना पड़ेगा। और इसको चाहिए XY प्रेशर। इंटरेस्टिंग। अच्छा, उसका सूडो कोड नहीं दिया है इन्होंने, कॉन्फ़िगर करना पड़ेगा ना, तभी तो आएगा ये सारे वैल्यूज। ओके, तो पहले हम लोग इसका हार्डवेयर कर लेते हैं, इसमें टाइम लगेगा यार। मैं एक करके ना फिर स्ट्रीम स्टार्ट करता हूँ, इसमें टाइम लगेगा, भी बजने वाला है। So we'll continue it tomorrow. There's a surprise, by the way. By the end of the video or end of this stream series, you will see what I am building with the ESP32 or LCD screen touch camera. But once we have the finished product, I will reveal it on the stream क्या बना रहा हूँ। Until then, bye bye.